Okay, so now let's move on to section 5 of chapter 6, and we're going to talk about bone development, which we also refer to as ossification or osteogenesis. And a couple things, like I mentioned previously, initially the fetal skeleton is actually cartilage and it isn't bone. So we don't actually begin making osseous tissue from our cartilage until about month 2 of development. And then we continue to have postnatal bone growth until early adulthood, depending on your age. I'm sorry, your gender. And then we have bone remodeling, so breakdown and build up constantly throughout our lifetime. So, formation of the bony skeleton. So, during the first 2 months, the embryonic skeleton is basically just hyaline cartilage and fibrous connective tissue. But around 2 months, the fibrous membranes in the cartilage, they can begin to be replaced with osseous tissue. And there's two ways in which they can do this. So we have what's called endochondral ossification, and we have intramembranous ossification. So looking at just at the name, if we're talking about chondro, anything that's referring to cartilage. So in endochondral ossification, we're basically replacing cartilage with bone. Then we have intramembranous ossification, and if we look at the name, we are developing bone from a membrane. So one's developing it from cartilage, one's developing it from membrane. The bulk of our skeletal system is built via endochondral ossification. If we're talking about our skull, that's going to be intramembranous ossification. So let's start with endochondral ossification. Like I mentioned, this begins around month 2 of development. And in order to build the bone, we have to break down the cartilage that was there to begin with. And I told you previously that the bulk of the skeletal cartilage of a fetus is hyaline cartilage. And how do we begin growing this bone? We have to start with what's called a primary ossification center, and that's going to be in the shaft of the diaphyses. What's going to happen is that we're going to get blood infiltration from our perichondrium, and then our perichondrium is going to turn into the periosteum. We also have some mesenchymal cells that are going to specialize in the osteoblast, so we can start building our bone matrix. So here's the first step with endochondral ossification. So initially, the perichondrium is surrounded by cartilage, but then our mesenchymal cells in our perichondrium are going to specialize into osteoblasts, and then our perichondrium is eventually going to become our periosteum. The osteoblasts are going to go in and secrete osteoid or the matrix, and when they do, they form this bone collar. And as they form the bone collar, our chondrocytes or our cartilage cells, they're going to hypertrophy or enlarge. And this is basically what the primary ossification center is. The second step in endochondral ossification is now that we have our hypertrophy chondrocytes, our enlarged chondrocytes, they're going to go in and calcify the matrix. So when they calcify the matrix, it becomes hardened and we can't get any nutrients to reach them, and then they die. So the matrix is going to deteriorate, and because of that, the chondrocytes die as well, and they leave all these open cavities. And these open cavities are basically the spaces within our trabeculae that we're eventually going to fill with marrow. Okay, the third step is that around month 3, we form what's called the periosteal bud. So our nutrient artery and vein and nerves, osteoprogenitor cells, osteoclasts, things that we need for red marrow, are going to form the periosteal bud. So this is the periosteal bud. And osteoclasts are going to go in and they're going to break down or resorb the calcified matrix. And then we have some progenitor cells that are going to differentiate into osteoblasts so we can start secreting the osteoid. And this is the beginning, basically, of spongy bone formation. Okay, the fourth step is we had our primary ossification center that we talked about that initially originated in the diaphyses of our long bone. So the primary ossification center is going to continue to enlarge during this stage, and our osteoclasts are going to continue to break down the spongy bone. Why are they breaking down the spongy bone? So that they can form the medullary cavity within the diaphyses of the long bone. And then shortly before birth, we get the formation of these secondary ossification centers in our epiphyses right there. And these secondary ossification centers follow basically the same steps as the primary ossification center, with the exception of the last step where osteoclasts come in to break down the spongy bone, because obviously we don't break down the spongy bone. The spongy bone remains in our epiphyses. So once complete, the only place that we can find cartilage remaining is basically on the surface of our epiphyses, and it's going to remain there as articular cartilage and at the epiphyseal plate until we stop growing in length, and then it becomes the epiphyseal line. Intramembranous ossification, like I told you, the big thing really here is that instead of beginning with cartilage, we are building our bone from a membrane. The biggest thing here again is to worry about what bones are formed via this route. Basically, all the bones that make up our skull, and then our clavicle bones as well. So these are the steps, and again, in order to build bone, it doesn't matter if we're talking about from cartilage or from membranes, we have to begin and create what are called ossification centers. We had a primary ossification center and a secondary ossification center in long bones. Typically in intramembranous ossification, we have multiple ossification centers. Another thing to keep in mind is that we don't have a medullary cavity in any of these bones when we're talking about our flat bones that make up our skull or our clavicle. So that means because we don't have a medullary cavity, we don't need any osteoclast activity. So that's another major difference. Okay, postnatal bone growth. Let's talk a little bit about that. So after we're born, how are we growing? So during adolescence, we get growth in our long bones by length. How do we do that? It's interstitial growth of our epiphyseal plate. So remember, interstitial growth is growth from within, and that's exactly what they're talking about when we're talking about the epiphyseal plate, or that plate of cartilage between our epiphyses and our diaphyses. We also have appositional growth, which is increasing the thickness of our bones, and appositional growth actually continues until adulthood. So interstitial growth, growth lengthwise, that only occurs as long as we have cartilage at the epiphyseal plate, and then we stop. But appositional growth, we are constantly doing throughout our lifetime. So let's talk a little bit about growth in length, and what we're going to focus on is that epiphyseal plate, because that's where our cartilage is. So in order to build bone, we have to do it from cartilage, and our epiphyseal plate is cartilage. So we have 5 different zones within our epiphyseal plate. They're shown here, but I'm going to talk a little bit about each one coming up now. So our resting zone, that's your area of cartilage on the epiphyseal side, so closer to the end. And again, what we're talking about, if this is our diaphyses or a shaft of our long bone, here's our epiphyses here. We have our epiphyseal plate right here. So now we're talking about basically the 5 zones that make up this epiphyseal plate, which is cartilage. So the one that's closest to the epiphyses right here on the top of it is going to be our resting or our quiescent zone. And it's pretty much inactive. That's why it's called that. Then we have just deep to that the proliferation zone. So this is the area of cartilage on the diaphyses side of the epiphyseal plate that is actually rapidly dividing. And as it divides, it's going to push cells upward. And what that's going to cause to happen is that the epiphyses is going to get pushed away from the diaphyses. So as it does that, we're going to grow our bone in length. Then we have what's called a hypertrophic zone, where the older chondrocytes that are closer to the diaphyses are going to be. And what are they going to do? The cartilage lacunae, they're going to enlarge or hypertrophy and eventually erode. And that's going to form those interconnecting spaces, or the trabeculae. Then we have what's called the calcification zone, and this is where our cartilage matrix is actually going to calcify. And remember, when it calcifies, it becomes hardened. We can't get nutrients to the chondrocytes that reside in there, so our chondrocytes are going to basically die and eventually deteriorate. And then our last zone within our epheseal plate is what we call the ossification zone. So this is our chondrocytes basically deteriorate and they leave those long spicules or those trabeculae of calcified cartilage. And then the spicules are then eroded away by osteoclasts and are covered with new bone by osteoblasts and ultimately replaced with the spongy bone that we know makes up the epiphyses of our long bones. Our medullary cavity is also going to enlarge during this process as our osteoclasts go in and break down the spongy bone. So here's a picture. Here's the epiphyses of a long bone. Here's the shaft or the diaphyses of a long bone. Here we can see, because we're not seeing actual bone, this darker line between the epiphyses and diaphyses is our epheseal plate, which is made up of cartilage. So this person is still growing in length. This would be fused together if we were no longer growing. So here's our different zones. The one closest to the epiphyses here is our resting zone. Not much is happening. I would be aware of the general things that are happening in the remainder of the 4 zones as shown to you on this slide, where we're actually undergoing mitosis and of which cells. So we're talking about chondrocytes are undergoing mitosis right there. Hypertrophic zone, that's where they're going to hypertrophy and enlarge, and the older ones, the older cartilage cells are going to go in and enlarge. The next step is we're going to calcify the matrix. Because we calcify the matrix, we can no longer get nutrients to our chondrocytes, so they're actually going to die, and that's when we can go in and start building our actual bone. Okay, growth and length, like we just talked about. So during adolescence, the thickness of the epheseal plate remains relatively constant. However, near the end of adolescence, our chondroblasts are going to divide less often. And our epheseal plate is going to continue to thin as the chondroblasts divide less often, and it's going to be replaced by bone. So then, once we're done growing in length, we have what's called epheseal plate closure, where our epiphyses and our diaphyses fuse. So when does this happen? Like I mentioned previously, it depends on what gender you are. For females, it occurs around age 16 to 18, and males around 21. So that was all about growth and length. And again, that only happens during adolescence and as long as you have cartilage at your epheseal plate. However, when we talk about growth in width or thickness or appositional growth, this occurs throughout our entire lifetime. And how do we know when to grow our bones in thickness? Well, it's based off of where we have the most stress, muscle activity, or weight bearing on our bones. So the osteoblasts that are beneath the periosteum are going to secrete the bone matrix onto the external surface, and then osteoclasts can come in and remove bone on the endosteal surface. So as we build bone on the outside, remove it on the inside, we basically are widening or making thicker the bone. Normally, we have more building up, so more osteoblast activity than we do breaking down or osteoclast activity. So that way we can produce like a thicker and stronger bone. So this is just an image of bone remodeling. And like I said, anytime we have bone remodeling, we have both bone building and both breakdown. So changes in the epiphyses also occur during growth and length, and that's just going to help maintain the correct proportions of bone that we need as well. I'm just going to introduce the hormonal regulation of bone growth. So several hormones influence whether or not our bones are growing. The growth hormone, as you probably know, is probably the most important hormone in stimulating epheseal plate activity, so influencing our growth in height or length. And when we're talking about during our infancy or our childhood, and it's released by our anterior pituitary gland. We also have the thyroid hormone, which can help modulate the activity of the growth hormone. And then we have our uh, testosterone and our estrogens at puberty, and these are going to help with adolescent growth spurts. If we have excesses or deficits in any of these hormones, we can get an abnormal skeleton growth. So, for example, if we have hypersecretion of the growth hormone, we can get something called gigantism. And if we get hyposecretion of the growth hormone, we can get something called pituitary dwarfism, which would be different from genetically based dwarfism.